Is known as a Brayton cycle. This is a continuous cycle unlike that of a reciprocating engine. The cycle is made up of four processes. The first process is compression, followed by constant pressure fuel combustion, then expansion in the turbine, which is actually consists of two parts: expansion power used to operate the compressor and the rest of the power used for propulsion or shaft power. Lastly, the air returns to its original state, otherwise known as an exhaust emitting into the atmosphere. We will discuss each process separately as they correspond to each section of a turbine engine. The first section will be the compressor. Air is drawn through an inlet into the compressor, where a spinning shaft with multiple airfoils forces the air through stator vanes or stationary airfoils, thus creating a high-pressured air. The compressor consists of multiple stages of compressor to stator vanes, depending on the required pressure for efficient combustion. After the desired pressure is achieved, the air continues to the combustor section. Now in the combustor, high pressure air from the compressor is mixed with the fuel at a predetermined ratio, depending on the engine requirements. This air-fuel mixture is then ignited, creating combustion, in which the hot gases created then flow to the turbine section. In the turbine section, the expanding gases are pushed through more airfoils attached to a shaft, now creating shaft power, somewhat like a windmill would catch the wind. This shaft is the same in which the compressor section is attached, thus driving the compressor once self-sustaining. Remaining power created by the expanding gases is either used as propulsion, like a turbofan, or as additional shaft power to drive a transmission, like in a helicopter. Some advantages to turbine engines are the use of FADEC, or Full Authority Digital Electronic Control. Also, turbine engines have significant power-to-weight ratio advantage over reciprocating engines of equal power output. Saving this weight makes for an additional advantage when used in flight due to the concerns of weight and balance in an aircraft. There are some disadvantages, however. Turbine engines are expensive, not only to manufacture, but to engineer as well. The fine-tuning required to achieve maximum efficiency is a process to which many man-hours are consumed. Time equals money. Not to mention, turbine engines are designed to run at constant speeds, for the most part that is 100%. Therefore, their idle, or least amount of load on the engine, is not fuel efficient. Whereas in a reciprocating engine, the revolutions per minute can be reduced when not under load, thus using less fuel.